Okay, we are in the concept of Kubernetes and just trying to ask. We are beginning Kubernetes today, and we should understand everything about networking right now because Kubernetes is all about networking. All right. Yes, Mr. Adrian, you wanted to answer what do you understand about orchestration?
Yes, I just wanted to chip in something like orchestration it's like a process whereby we replicate as many containers as possible that is able to host our container or an application for it to run as intended.
A situation where we replicate our applications for it to run as we intended. Okay, that one
Or container.
is making some sense in a very common way. That is a situation where we replicate our containers for them to work as we expect or as we want. Well, that is a layman's way of looking at it. Now, I want you to be comfortable with this word service. I want you to be comfortable with this word service. This word like this service. Let us try to look at the word the way it is service. When they say service, what do they mean? What do we mean by service? If we say service, what do we mean by service? In anywhere, in any direction that you can think of. I'm not like trying to limit you to computer science or IT or Kubernetes or Docker, anything. We talk about service.
So I think it's like um how can I put it? Uh, Giving into what people demand, or giving, how can I put it? Serving people with resources, resources,
It's quite funny.
or providing I don't know, assistance.
If they ask you to define service in economics, wouldn't you be able to define service? They say, okay, if a child enters and asks you, what do you do? Uh, you say you render services as what? As a teacher. Is that true? You render services as a teacher. Okay?
Yes,
That means you have a particular duty that you do. Not so, you have a particular duty that you do with a talent that you have. That is service, right? And with that your
yes,
particular duty that you do with a talent that you have, a particular work is being done. That is true, not so? The talent that you have, you render a particular duty to somebody. Don't forget, to somebody. Okay? To somebody. Because that is where it becomes service. If you are doing it to yourself, it is no more service. You are doing it to somebody. That is where it becomes service. Okay? Now, instead of employing people to work for us, what we do is we employ applications. Is the concept coming? Instead of employing people to work for us, we employ applications. Example, I need the services of somebody to be able to take all the various commands of people who want to buy my air ticket from Cameroon, from Nigeria, and from Ghana, and take all those people and show me how many people are in need of my ticket. That is a service that you are in need of. without applications, you are going to employ people to go to Cameroon, to go to Ghana, to go to Nigeria and do all those activities. Okay? But with applications, these applications are going to run and people will be able to access the applications and do their demands directly. So that intermediary service of that man that you needed is no more there. Okay? So the service here has been performed by your application. Okay. Now, with this idea of the fact that applications perform services, you will constantly be hearing that which service is this, which service is that, which service is this. When you hear in IT they talk about which service is this, they are asking you, this application, what is it doing? If you hear they talk about in Kubernetes, which service is this in Kubernetes, within Kubernetes? Therefore, it is an action within Kubernetes that is helping Kubernetes to perform its duties. I hope we are following up. So, this is what we have. We have an application. This application takes in commands from people. And as it takes in command from people, it gives out the result of how many people are in need of those commands. This is that application, right? This application is running inside a computer. Okay? This application is running inside this computer. All right. Now, Kubernetes comes in to talk about orchestration. And orchestration is making computers perform the same service as if they are one. There is a difference between orchestration and networking and connection. For example, I will have the second computer with the application inside. Now, this application still performs the same actions like the other one was performing. But the difference with this is that this architecture behaves as if it is one. This architecture behaves as if it is one. You that is in front of you, that is asking for these demands here, you don't know whether traffic is coming but from this one or from this one. You don't know. When you launch traffic at one moment, it goes here. When you launch at another moment, it comes here. That is orchestration. Now you might have a question. What is the difference between orchestration and networking? Now, look at how networking is. In networking, this computer here connects to this computer here, connects to this computer here. The network is linked from this computer to this computer and linked from this computer to this computer. That's how the connectivity is. Now, if you want to get to this computer here, this one here, you have to pass through this computer, and then from this computer you go to this one, and then from this one you go to this one. This is networking. But you cannot sit here and at the same time you get every information that all these computers are sending. You have to pass through one to the other to the other. That is network. But now orchestration changes it and says that I want to make it possible for you to sit here and launch a call here, and this call can come to any of these computers. This is orchestration now. So that is the meaning of orchestration. If you don't grab orchestration very well, you will keep confusing orchestration with networking. So to put it in technological terms, orchestration is the combination of containers and instances to serve a particular service. Here the way I use that word, to serve a particular service. That means when all these things come together, what do? They serve a service. Remember that we said applications perform service. So these things put together serve this service in the sense that all the services that this thing was offering are now being orchestrated in as many computers as possible. That is orchestration for you. So what is Kubernetes and how does it perform this orchestration? That is what we are going to be looking right now. So Kubernetes, known for its generally is known as K8. It is known as K8, I think, because if you take the name Kubernetes, one, two, three, four, five, six, seven, 8. Okay. You see, I don't see any linkage with 8 with Kubernetes. So they always put it K8s. So you have to find out why it is always often called K8, because even in their official documentation, they are referred to as K8. So Kubernetes is an orchestration tool. Remember our definition and modality. What is it? It is a tool. What type of tool? An orchestration tool. Kubernetes is an orchestration tool. We have explained orchestration. Let us look at the architecture of Kubernetes. Now, the general architecture of Kubernetes is made up of one big master machine, just like Docker, and there are going to be several workers, just like in Docker. Now, in Kubernetes, there are different components installed in different instances. The master, this one is the master. The master has a series of components, of which are, the first one is API server. We'll come to what all those things do. The second one is kube scheduler. The third one is kube controller manager. The fourth one is etcd. These are the components that are in the master. Now, what are the components that are in the workers? In the workers, you have the first component is kubelets, and the second component is kube proxy. This is the architecture of Kubernetes. So these very two are also replicated here. This one has kubelets 2. In all interviews, please, in all interviews that you ever have, they will ask you to explain the architecture of Kubernetes. In all interviews. This one is kube proxy. In all interviews, they will always ask you to explain this very architecture. Now, just have it in mind that there are 4 things that are installed in the master, and then there are 2 things that are installed in as many worker nodes as possible. Okay. Now, the first thing is, how do these things work? They work in connection with each other. How is the movement of work? The API server that is here acts like a receptor. Everything that you are going to be writing, every command that you will ever be writing, will be received by the API server. The API server is going to receive all your commands that you are going to be sending to Kubernetes. The API server receives the command. When the API server receives the command of what you want Kubernetes to do, generally you will always want Kubernetes to do so many things. So you will be asking Kubernetes, can you please do me this? Can you please do me that? Can you please do me anything that you want? We will come to everything that Kubernetes does. When you send that information, the information is received by the API server. What does the API server do? The API server authenticates your in Kubernetes. Information is going to be sent in files, in YAML files. So the API server is going to authenticate your YAML files and make sure that they are in conformity as they are supposed to be. Okay? When it authenticates, then it will pass the information to the kube scheduler. The kube scheduler will then look at the information that you want. And with respect to the particular information that you want the kube scheduler to do, the kube scheduler will then schedules, just like its name says, schedules the information, the action to be performed where? In the worker. The kube scheduler schedules the action to be performed in the worker. But can the kube scheduler just schedule this action and say be performed in the worker directly? The kube scheduler communicates with the kubelets. It communicates with the kubelet. It tells the kubelet that there is a request for you to create certain things. And I don't know, I want you to create those things in your particular environment. We'll come to the various different environments. I want you to create those resources in your environment. Kubelets then take that information and looks at the information and says, okay, you wanted this information says that I should create a pod. I can create a pod in my environment. Kubelet then position a pod that will be created inside its environment. This pod is created here. When this pod is created, what happens? kubeproxy assigns an IP to this pod in a particular ascending order. kubeproxy assigns the IP to the pod that has just been created. Now, when an IP has been assigned to this pod, the next thing now that is done is controller manager always scans the whole cluster every after a periodic time. That means controller manager scans this cluster every after a particular period of time. After that, it scans again the cluster. After that, it scans the cluster. Question is, what is controller manager scanning this cluster for? The controller manager is scanning this cluster to make sure that the cluster configuration as it is here is directly what is found in the etcd. We'll come to what the etcd does. So the cluster manager scans the cluster, or the controller manager please scans the cluster and discovers that something is happening that is new. That thing that is new is the positioning of a new pod. Now the controller manager then picks this pod that has just been created. It picks the pod that has just been created and it sends the information of this pod to etcd and say, etcd, update to your database. There is a new person that has just come in. So who is etcd? etcd is that environment where it keeps the track. It is that person in the house that takes down the roll call, performs the roll call of everything that is happening in the cluster. It is like a small mini database. It takes down the roll call of every single thing that is happening in the whole cluster. So controller manager scans the whole cluster, gets an update of what is new in the cluster, and then sends the information to etcd. etcd updates its database. Controller manager, as you hear the name controller manager, is also responsible for doing replication. It can be controller manager, it can be replication manager, it can be anything. So it depends whosoever is acting. Only one pod has been created. But what if in your YAML file you decided and said, I wanted 10 pods to be replicated? It will be a replication manager that will now get in here and start replicating the same thing that has been done here into different instances in the cluster. So at the end of the day, what happens? All this environment is being kept under the watchful eyes of the controller and data being stored in the etcd. That is the architecture of Kubernetes. Is there any question?
Not really, sir. It is good. It's good for me.
It's clear, right?
It's clear, sir.
Okay. All right.
So I saw an element. I saw that means ports now simply means
We'll come to
when
that.
the
We'll come to
containers
that. We'll come to
or
that. We'll come to that.
workers are
We'll come to that. Don't worry
okay.
yourself. Don't worry yourself. I'm not. I cannot
Yes,
just
please.
introduce pods like that without actually without explaining to you what they are. We'll come to that. I just wanted
Okay,
that we
sir.
finished the architecture of Kubernetes the way it is, so that you understand the architecture first. Understand how the architecture is, how it performs its duties first. Because the most important thing is understand this architecture first, and then from there we shall be working with the architecture and performing and explaining other things from this architecture. Okay, so the very first thing is
Okay.
understand the architecture. Mr. Kiba, is the architecture understood?
Uh, sorry, sir. I had a problem with communication. I thought it was my Wi-Fi, so I logged in and logged out. But it's understood, sir. I missed out a few things, but I will catch up, sir.
All right. Okay, that is the architecture of Kubernetes. Now, with this architecture, I have used the term pods, right? I've used the term pod so many times. Actually, Kubernetes has what we call objects. In Kubernetes, its components are called objects, right? When you are in Kubernetes, you always hear of Kubernetes objects. So what are Kubernetes objects? What are Kubernetes objects? These are all the various components that are found within Kubernetes. They are the services that are found within Kubernetes. These are all the various different services that are found within Kubernetes. Okay? The Kubernetes objects. So, there are so many of them. There are so many Kubernetes objects. But we will start from the basic one, which is what you just asked, Declan. First, what is a pod? A pod is a Kubernetes object. Let's start with number one, pod. What is a pod? Now, from now, we have learned that we take Docker images, right? We take Docker images, and from Docker images, what do? We run Docker containers. This is what we have been doing, right? We take Docker images, and from Docker images, we run Docker containers. And we can run from one single image, we can run as many as containers as we want, right? We can replicate the containers. From this image, we run containers. That is what we all know, okay? And these containers, they exist like containers. These containers exist like containers, okay? Now, with Kubernetes, Kubernetes has what we call, it comes with what we call an envelope. Instead of running a container for that container to be as a container, Kubernetes comes now, and when it sees the container that you want, it envelopes that container. Kubernetes actually envelopes the container. Okay? When it envelopes the container, now this envelope is what we refer to as a pod. Kubernetes envelopes this container, and the envelope is what we refer to as the pod. Now, there is a communication linkage between the container and the pod. This pod can be made available with a Docker engine inside or any other containerized application. There are so many containerized applications, not only Docker. I hope you know that. There are several different containerized applications, not containerized tools, not only Docker, but the widely used is Docker. Okay, so there are communication tools between the container and the engine of the pod. Okay, so Kubernetes comes now, envelopes this container, and the container starts acting but inside this envelope, and the container and its envelope is what we refer to as the pod. So looking at this place, you will see that Kubernetes takes an image of Docker, and instead of deploying a container, it deploys directly a pod here like this. Okay, Kubernetes takes an image and deploys a pod directly. So a pod is just a container, a running container that has been enveloped. Question: can you get into a pod? Yes, if we could get into a container, then we can get into a pod. We can SSH into a pod. We can exec into a pod. Okay, we can exec into a pod. And actually, the pod is an example of a standalone service. I come back to that word. The pod is an example of a standalone service. One pod can give the job, can do the job. One pod can do the job. So, if you already have one pod that is existing, that particular one pod is capable of doing the job. So, the multiplication of this pod is just a way of making the job to be done more efficiently. One pod is able to do the whole job that you need. One pod is the main thing that is just necessary to do the job. So that's the first thing that you should know. A pod. Okay? The second object of Kubernetes that I will want us to study today is called where are we? Okay. We have looked at pods. The second object of Kubernetes that I want us to study today is a service. A service. What is a service? What is a service? Now we are within Kubernetes. So, what is a service? A service in Kubernetes is that object that gives, look at the word I'm going to use, that gives an attribute. It gives an attribute. Take care of this word. A service gives an attribute to a pod. Please, listen very well. A service gives an attribute to a pod because a pod is just created like that. Just a pod like that. But a service now then gives an attribute to this pod. Let me take the example of a daily life synonym. You have a phone, right? Everybody has a phone. But can you communicate with that phone just from buying it from the market? It is absolutely impossible. What do you need? You need a service. What type of service? Either a mobile network service. In Cameroon, you can talk of you have MTN service, you have Orange service, you have Camtel service. You need a service in order to communicate with your phone. So pods also need a service to perform their duties. there are so many different types of services as we are going to be seeing. So most often services gives the port their port numbers. Hope we are not going to get confused here. Services gives the port their port numbers. We know what port numbers are used for, right? They are mostly used for communication. So a service gives an attribute to a port. So it is a service that is going to decide what kind of a port that you are having. It is a service that decides what type of a port that you are going to have. Okay? That is the first thing I would like you to know. When you are making your notes, please use my lectures and make your notes. I don't think you are going to have these particular lectures anywhere, wherever in the internet. Because I understand my own things from a very dull man point of view, and because I learned from that point of view. Because in the internet they will be explaining to you, hoping that you are an IT engineer. Okay? So so let's go ahead. We are finished with service. Now, these are the various two types of Kubernetes objects that we have. So we are going to start looking at the various service objects that are found. There are so many service objects that are found. Okay, we are going to take a look at all the various service objects one after the other, and we are going to treat them one after the other when we start doing hands-on. Okay, so what is Kubernetes then used for, and why is it more talked about? What is the magic behind Kubernetes? Why is it better than Docker? That is a question that we need to answer before we go. The first question is that Kubernetes performs these roles. Let us start naming them. Number one, Kubernetes performs auto-scaling. Kubernetes performs auto-scaling. Did we see auto-scaling in Docker Swarm? I doubt. What you saw was scaling. You saw scaling in Docker Swarm. You never saw auto-scaling in Docker Swarm. In Docker Swarm, what you will do is you will actually scale up the containers or you scale down the containers. But there is no possibility for you to make it such that the containers are scaling themselves up and down without you controlling anything. Kubernetes does auto scaling. That's the very first thing about Kubernetes. Kubernetes does auto healing. Of course, Docker does auto healing. We know about auto healing, right? When a pod gets destroyed and the priority of that pod is to always get started, immediately it gets destroyed, what will happen is that another pod will be generated. That's the second good aspect of Kubernetes. It does auto healing. The third one is load balancing. We know about load balancing from Solution Architect. When we are doing Solution Architect, we saw what is load balancing. So Kubernetes is not in need of a load balancer or whatsoever. Kubernetes performs its load balancing alone. So Kubernetes is capable of performing load balancing. Okay. Then there is one thing, Kubernetes performs rollback. Kubernetes performs rollback, which means as you are performing your upgrades and doing your deployments and going, if anything breaks along the way, there will be a possibility for you to roll back to where you were from the starting point. Okay, and then without much emphasis, it performs orchestration. it performs orchestration. Now we have learned about what orchestration is all. We know about the joining of machines together to perform their duties. That is orchestration. Okay, so these are the various features that Kubernetes do. So we have orchestration, we have auto scaling, we have auto healing, we have load balancing, we have rollback. Okay, so with all these uh, uh, performance and potentials, Kubernetes is highly preferred to than Docker Swarm. I don't think there is any company in the industry again that is using Docker Swarm. I doubt it. I very much doubt it today. So everybody is using Kubernetes. Everybody has migrated towards the use of Kubernetes. So these are the various advantages that Kubernetes is going to have over Docker Swarm. Okay, so this is the this is the lecture in Kubernetes is going to have a lot of theoretical explanation, because if you don't understand the theoretical explanation, you are going to get lost in everything they are practicing. Totally lost. Okay, you are going to get totally lost in everything that we are practicing. All right. So far so good. Any question?
Not really, sir.
Okay. Good and great. All right. We are short from getting 1 hour. Let's make the classes as short as possible, not too long. We are going to set up a Kubernetes cluster. Setting up a Kubernetes cluster is one hell of a task. Okay, we are going to set up a Kubernetes cluster, but it is possible for you to set up. It's possible for you to set up a Minikube cluster, and we practice with a Minikube cluster. It will be good to set up a Minikube cluster than setting up a real Kubernetes cluster. It would be better to set up a Minikube cluster so that we practice with the Minikube cluster. So I believe that on Tuesday we are going to set up a Minikube cluster where we are going to practice how to first of all uh, install or run a pod in Kubernetes. We are going to run our first pod in Kubernetes and see how the pod performs and access the pod just like we used to access containers. And then from there, we are going to start now evaluating those nice properties of Kubernetes. We are going to have secret objects. We are going to have namespace, talk about namespace. We are going to talk about the replica set controller. We are going to talk about deployment objects. We are going to talk about those major core concepts of Kubernetes, which makes it actually the reality of the game changer. I think next class is a no miss class. Okay.
Okay, sir.
All right. We'll stop the recording here.